Welcome. My name is Brant Sutton, I'm a clinical specialist with Össur. And today I would like to talk to you about our Össur solutions, primarily socket solutions. As I like to say, anybody can kick out a widget or a foot or a knee, but at Össur we provide the entire top to bottom setup. As a clinician, we all have all these different things that we need to do. So anything that we can do to help you get more of your time back, I believe is where we really thrive. I can speak personally that in private practice, seeing patients was was my favorite part of the deal, but it was such a small percentage of the time that I actually got to spend. So in utilizing Össur's solutions, I'm able to better address healthcare's triple aim. And in that, we all, have to follow these, both from a professional aspect and a service aspect. And in doing this, I find that, the patient is what is most important. In our Össur leg solutions, we have multiple different ways to get you the service for your patients that you need. You choose the service, and we allow you to get there. We have our leg packages, which are both financially and ease best. The Design Studio, which is our CAD CAM, and teaming up with Central Fabrication in Orlando, we have the Connect TF, which is our adjustable low active socket solution for transfemoral. Our direct sockets, which is our hands-off repeatable process, which is become the pinnacle of socket technologies. We have the Pro app, which is our outcome measures, and our Össur portal, which gives us the ability to order things either a la carte or in packages. And then, of course, the clinical education support. So in looking at these things, why use Össur solutions? Well, we have from patient focus all the way to the COGS and savings. And first, what I believe is most important is the patient focus. We have optimal clinical solutions. We can do this through computer-aided design. We can do this through traditional fabrication and direct socket and Connect TF. The Pro app is also our outcome measures. This is where we are validating the correct prescription. We are validating to our referral sources that we're actually doing what we are claiming to do. We are validating to the insurance companies that we are actually providing the services that they are paying for. And we are able to show the patient and the family that they are progressing. They are making progress, because too often when they see themselves every day, they're not able to really see how far they've actually come. And with our measurable outcomes, we can actually see that the patient is progressing. This also goes into the healthcare triple aim in that we are improving patient outcomes, we are improving cost efficiencies, we are improving patient satisfaction, and we are providing a tool to record these objective outcomes. In talking about efficiencies, so the one thing I always look at is billable events. And reimbursement does not increase with more time and more effort being invested. Your reimbursement doesn't increase there. So in efficiencies equal billable events. The optimal fit and function with fewer non-billable events. So in our different our different ways of getting to the finished product, allow you to pick which way you want to go. And then we have our COGS, so our cost of goods and services. And too often we look at this as simply raw materials and labor. So our COGS are also the time spent once the service is rendered, our office staff and getting ourselves paid, our follow-ups, our adjustments. Regardless of the number of visits, again, reimbursement does not change. So with Össur Portal, we have our one-stop shop, bundle and save. We've got our, legs, which equal, the complete leg, which is everything: socket, liner, suspension, knee, components, foot, everything you need. We have the socket only, which is liners, a socket, and a suspension. And then we also have the socketless, which is liners, suspension, knee and foot if you want it. And also a la carte ordering. So we can order just what we need, a part, liners, anything else for any individual patient or the clinic itself. It also tracks the shipping and our order tracking. We have a way to keep a single area for our scans of patient limbs, our measurement forms, and our component history. So 6 months from now, when you want to replace liners, we can see exactly what we provided for that patient last time without hunting it down and ordering the wrong liners. As far as you choosing the process to actually have things done, we have the hands-on approach where you take a cast. We have the hands-off direct socket, and we also have the computer-aided design. So with these outcomes, or with these processes, any of these can be done through Össur Solutions. The computer-aided design and the hands-on, casting can also be done at, fabricated down in Orlando. We have a state-of-the-art facility with lean manufacturing. It is your off-site lab, staffed by skilled designers, technicians, and clinicians. You get all the benefits of a team that knows exactly how to deliver what you order for your patients. You're in control, and you choose when to turn to the Össur Leg program. Speaking from experience, Össur Custom Solutions is your fabrication, materials, and labor costs are fixed. So you've got a prosthetist to watch out for your process, and it will save you time and money. Next I'd like to discuss is Design Studio. And the one thing that I always run into when talking about computer CAD is I get told that CAD can't do what I can do with my hands. Well, my argument is to that I used to feel the exact same way. I've been in the field for almost 30 years now, and I was that guy. My hands are the magic. But what I did learn is that my hands can't do anything without my mind. So I have found that your mind is your greatest tool. And that's where CAD comes in because of the efficiencies. We eliminate the plaster, and we are using technology, using CAD software built from the ground up for prosthetists. Our built-in workflows support your unique craft, so you can have repeatable outcomes. You can greater engage your customers, your amputees, and I can speak again from personal experience that an engaged patient is a committed patient. They fully understand that you are doing the best for them, and you are involving them in the process of designing and fitting and fabricating and taking care of their needs. So I highly recommend involving your patients regardless. And then let's not forget the clinical documentation and justification. Too often, insurance companies are fighting us on absolutely everything that we are doing, and we have to justify, what we are providing. With CAD, the scans of the limb and the measurements, a picture is worth 1,000 words. It's hard to argue with, the previous limb, and the current size and shape is very obvious. So it does lend to fewer denials and fewer appeals in providing services. I'd like to show you how easy it is to actually achieve a scan. That is one thing that I'm constantly told, that scanning is difficult. And let's run this video. So this is a screen capture of me actually scanning a patient's limb, and we are deciding which aspect we want to take. When we stop, you see the little blue bar that asks us to take a picture. I am only stopping when I want the camera to actually take a picture of that limb, so that I can actually get the markings that I have applied to that limb for different landmarks, whether it's the fibula or the tibial plateaus, tibial crest, and my length marks. And then from there, those will actually show on my model, so that when I am doing my designs, I can see it just like I drew an indelible pencil on a plaster model. Once we have the design workflows, so we have workflows that allow us to create a design that is your modifications that are scalable to each individual amputee and limb. So we are going to take our scan, we upload this into Design Studio, we're going to check it over, make sure we don't have any flaws, clean up, delete anything that we need to, and then we're going to open up a new workflow. And over here on the left there, you can see all of our workflows. These are the things that we have previously made modifications. So, Brandt's perfect fit is Brandt's perfect fit. So I want to apply that to this new patient. And how we do that is we set landmarks. So by identifying landmarks to this model, I am applying and scaling my personal modifications to this new limb mold. And once they are identified, the system will then look to see if it has enough space for trim lines. It does that all on its own. I'm going to take my measurements. So I am consistent in taking my measurements, and I'm going to apply those measurements to my model. So we have to apply measurements because a scan can't compress the limb. So our measurements are a compressed measurement to create our actual measurements of our limb. So when you take a cast, you're actually wrapping that and compressing it. So I'm doing the same right now. The bottom measurement is too far outside my model. It's just down there at the distal end. So I'm going to take it out of the equation so that the system doesn't try to average it. From here, we can make reductions. We can do global reductions or at each interval. Or in this case, I used a casting liner, Össur casting liner, which will retro straight into a 3mm liner with no reduction. From here, I've got all my areas. And because I drew on my model, I can actually see where I drew. And I can fine tune and move my different modification regions to reflect the areas that I actually want to make modifications to. From there, I can also create how much modification I want to make. So right now, I've generated a 1 centimeter posterior shelf, and I can go up as high as 2 centimeters. I can go all the way down to 0. But each individual area I can actually make modifications to. I can set in a patella bar. I'm not much of a patella bar guy, so I'm leaving that out of the equation. And then my tibial crest. So I got my bony areas that I want to create reliefs on. We can set the area that we are applying the buildup to and how much. Again, my tibial flares. So we can set these up for if you want to do a total surface bearing with global reductions, or as many modifications as you can possibly think of here. And then we're just going to make little fine-tune adjustments to our template that we have created to actually apply to this new model. Fibular head came out pretty darn close for where I marked it. And then how much of an area, we need a little bit more buildup on this. And then the anterior distal tibia. How many times have we complained that, somebody's complained to us that the distal tibia? Well, we can actually target that specific area if we want to. Create a little deeper relief just there. Once we're set with all these, we're just going to move on, and the system's going to give us a review of our measurements so that we can actually see what our modifications did to the model. From there, we're going to go to global smoothing. I call this the feel-good slider. So depending on how much smoothing of your modifications you want to make, it does not change the volume of your mold, just smooths in your modifications. From here, I'm going to set trim lines. With setting trim lines and actually trimming our model, when you send that to Orlando, we will actually put that into a mill, and the mill will actually carve out the trim lines so that the only thing a technician is doing is buffing the plastic. So you get exactly the trim lines you want. From there, we can put a little flare on it. I like the flare, for a locking liner with a larger thigh, and I like no flare with a sleeve suspension. But from there, if we've made a great deal of changes, we can actually save a new template. I do advise you name it something different. But then we're going to finalize this and take it into a manual tools aspect. From here, I can inspect my model. If I look at this, when I donned that liner on that limb, it wasn't quite perfect. So I want to fix that before I send it in for fabrication. So I'm going to straighten out my little accident that I did in donning that liner by bending the model to make it as though I did don the liner perfectly. From there, once I'm done with that, I can save this and I can actually order a socket. So from here, I just go right in. I'm going to tell the system what I'm doing, what I want to do, where I want it shipped to. I'm going to give it a purchase order number so that we can track it, my patient ID, and then essentially I'm just going to build my work order right here. I can also tie this in and order it directly in through Portal. But in this case here, we're doing a manual order for the socket itself. So I put in all my pertinent information, my material that I want to use. I can get a flexible inner socket with my diagnostic if I want. I'm going to set my suspension type. And then that it is a fully modified model. Since I do have a hybrid suspension, we're going to have a 0-0. And since I really don't want to build one on this, I'm just going to tell them that, hey, this is a demonstration. From here, if I want to save the file or tie it into a portal order, I can just download the file right here. I can name it whatever I want. I can put the patient's name. I can put identifiers. I can put the date so that I can keep track of these files. But in Portal, I have a one place for all my information. So from there, once that's done, we can send this off. The thing is with Design Studio just saves you time, but it also saves you money because we are saving time. I just fully scanned, modified, and ordered a socket in about 7.5 minutes. I can't even get a plaster cast to set up in that amount of time. So it is very efficient. On top of that, I'm not actually sending a cast, so I don't have to worry about shipping times. That instantly goes into fabrication. So I have saved 2 days of shipping by actually sending my digital file rather than a cast for fabrication. So it's very efficient. It's very accurate. I always, thought myself when I was doing, modifications to a cast manually, my margin of error was, 3 to 4 millimeters. With CAD, I know that my margin of error is within the millimeter because I can actually see exactly what I'm changing. The measurement is following the contours of the limb rather than bridging over different areas. So it makes us much more repeatable and much more accurate. So again, we have repeatable outcomes. So from Design Studio, apologize here, it's fine, there we go. So if you would like more information about Design Studio and you want to sign up for Design Studio, scan the QR code. It'll take you to the form where you can sign up and get more information and learn more about Design Studio. You can also talk to your AM and they can put you in touch with me. From there, let's talk about Portal. So Össur Portal is our, again, ordering. There's another QR code there if you want to learn a little bit more. But Portal is where we can build our packages. And I had said that, it saves you time and money. So when I talk about saving money, we actually have packages designed for both transtibial and transfemoral at different K levels. So when I am designing a transfemoral K2 mechanical knee and foot, I am purchasing a package. And inside of that package, regardless of what liner that I'm using or which knee in that K2 package, my price is fixed. It's the same thing with the different levels. So I can have a microprocessor package, I can have a K3 level package, and it keeps your prices fixed and it saves you a substantial amount of money. We also have the order forms that you can do it the old paper way. Portal does make it easier because it's a hierarchy. You can also, scan directly into Portal. So as we scan into Portal and we don't want to go through all the modifications ourselves, we can actually scan in and have Össur's designers design us a socket. So from there, I can also scan. Okay, we're good. All right, so we are live. So scanning into Portal is getting the exact same quality of mold that I had generated through Design Studio, but it's going directly into Portal so that I don't have to do the modifications. I can have my designers do the modifications. So I'm going to give them the scan, I'm going to give them my measurements, and they will design it for me from there. So once that's done in there, then I can also upload a scan. So uploading a scan is literally where I just did the Design Studio model that I had downloaded. I'm going to put this into the file so that I both have the modified file that I created as well as the directly scanned model. I have them all in one place, and I can choose which one that I want to utilize for my fabrication. And then we can see them both there in the same place. So let's look at how do we go about building a order inside a Portal. How complicated is this? Well, let's run through it. So in Portal, we're going to create a leg. So I've got all my patient information in there. I've got my measurements, my patient weight, their activity level, their side, their foot size, and we're going to go through and we're going to select what is our suspension type. In his case, I want to do a hybrid, locking with Unity. I'm going to select my liner size, and it's going to filter and provide me a step-by-step workflow, just like we did a workflow in Design Studio. It's going to walk me through the ordering system here. I'm going to get little green check marks so I get rewarded when I actually do it properly. And it's going to build the whole process there on the right side so I can actually see what I want to build. So I can select, decorative laminations. I can have flexible inner sockets. I can choose my materials. And these will be tailored to my patient. We're going to set our check socket, and again, we can choose what material we want to use. And then I can have my passive, I can have my unity. And then when I select my prosthetic foot, it's going to allow us, because we already know that the end of my socket has a male pyramid, we're going to select our foot. And we have all the feet that are appropriate for that weight and activity level. And they are the side and the size. So once I select my foot that I want, I'm going to select my color and then my category. So it's always going to give you the category and possibly the category up if the weights are close, so that you have options on the foot. From there, we're going to select our components that connect a male to a male. And I'm going to use the height adjustable pylon because my patient is at 220, which is right there at the cutoff. But these are so handy because you can actually just spin them out or spin them taller or shorter. Once that's done, I get all my check marks over on the side. It asks if I want to add more components, which I don't because I've got everything I need. It's going to give me my clearances and tell me how much room I got to work with. And then we can go through and we can actually order this. Then once this is done, we can configure our sockets. So I'm going to build my check socket, and this is where I'm going to decide, do I want them to do it, or am I actually sending my scan? So in this case, I want to use the CAD file that I created. So I'm going to choose the one that I downloaded. I'm going to attach that to this model so there's no confusion. I'm going to put on there that I have trimmed this model. So it's, the trim lines are on my model. And the modifications were also on my model. I don't want them to do any modifications. And then my standard alignment, because it is a pin, I want it to line up with the distal end of my limb so that the pin engages. How much assembly do I want them to do? I want them to attach my lock, but I don't want them to put the components on or anything. And then we're going to submit this for manufacturing. And then we can actually follow this and see when we're going to get it, where it is in the processing aspect. And that is how simple it is to actually build a prosthetic socket. So from there, let's talk about ConnectTF. So ConnectTF is our right here. It's our adjustable socket. It is targeting our lower activity users who have typically struggled with usability and comfort. It is designed to be more comfortable and easier to don and off than a traditional conventional socket. And it allows us to address a wider range of amputees. Too often we get these low active amputees that have a lot of medical issues that limit their ability to use a prosthetic. But with the ConnectTF, we have that ability to actually provide these people the opportunity to get out of a wheelchair and actually walk. It is more comfortable while sitting. Too often, these lower activity people, they spend a higher percentage of time sitting. And if the prosthetic is not comfortable, they're not going to put it on. And if they're not going to wear it while they're sitting, then why would they put it on to get up and walk? So we need a prosthetic that they're actually going to don while they're sitting, wear while they're sitting, so that they have the opportunity to stand up and walk. The ConnectTF does this. The medical necessity of it is, let's go in and look at this slide here a little bit more in detail. For the low active user, We have that sitting and load-bearing comfort. We have the ability to make transfers and walking. Ease of donning, the socket can be opened and closed with little physical effort. It is not confusing or difficult to use, and it's very quick to put on. For the practitioner, we have clear size selections. It's fast and effective in the initial setup, and the fit can be modified and optimized on the patient. There's more time for clinical work with the user so that it is quick to put the socket on, get it fitting properly, and then you can actually work on with the amputee and actually walking and donning and doffing. Comparing it to other options that are out there. So, conventional fabrication is, again, these multiple visits of getting that person in. And again, as we talked before, reimbursement does not increase with more visits. So we have our measuring visit with a conventional socket, our shape capture, scanning or casting, taking measurements, modifying, rectifying that model. We have the check socket, the aligning and the fitting, as well as the final delivery appointment. With like the limb systems, those modular, more custom adjustable sockets. We have the ability to, or the multiple visits. We don't have to rectify, well, we do have to rectify them all, I apologize. We don't have necessarily the check fitting, but we do have the adjustment of the fit with the socket as well as the final fitting there. With the Veros type socket, we have a socket that is measured for. The socket comes to you unassembled. It actually has to be assembled. The uprights have to be cut to length. Then once that's done, then you actually put it on, you adjust the fit, and then you have, you can have your final fitting there. With the Connect TF, we have a measuring, we have a second appointment where we actually do the adjustment of the fit on the patient, and we can deliver it that day. If we want to make changes to it, we can undo anything that we did. Because the socket is adjustable, so looking at this, because the socket is adjustable, the uprights do not have to be cut. So the socket can be lengthened or shortened, and then the angles on the bottom can be adjusted, and the tensions of the socket are set by us. The practitioner sets the adjustment because we are, again, targeting our lower active amputees who may not have the hand strength or possibly the cognitive ability to make their own socket fit properly. So we are going to make that clinical decision for them. The socket has a lever on it that allows them to open it so that it is easy to don, and then close it up to take it to the tightness, the appropriate tightness of the socket that we set. They all use the locking liner with a clutch lock suspension. So we've got a large button down at the end that can be tightened down to draw the amputee down fully. And then it's a big button that's easy to pull to doff. So again, the socket can be opened up and taken off easily. See if that'll stand up again. All right. So how do we fit one of these? Well, it's just like fitting a liner. Because we are using an Össur locking liner, whether it's conical or standard, we're going to make our size selection just like we normally would for the locking liner. From there, we're going to take measurements of our amputee. We're going to measure just like we would on a limb. So we're going to measure for the liner size, and then our length from perineum to the distal end. From there, we're going to use our chart to select our sizes. We have 4 different sizes. We have a medium short and a medium standard, which is the length. And then we have a large short and a large standard. So we can fit, many different limbs. Össur is estimating that we're fitting 60 to 70% of the balanced TF amputees. The current sizing fits liner sizes between 26.5 and 40, and residual limb lengths of 200 millimeters to 280 millimeters. The clutch lock comes with a pin that is 12 notch or a 40 millimeter ratchet pin, so that we can actually don this easy and draw them down into it properly. And then when you want to talk about billable events, your second visit is a delivery. So you've got 2 visits essentially to get to your billable event. The QR code there will also get you more information about ConnectTF. Let's talk about the modern prosthetist. I love this quote. Amateurs practice until they can get it right. Professionals practice until they can't get it wrong. So what's the difference between a professional and an amateur? You know, is it good versus great? So with this mindset, I'd like to discuss the pinnacle of appropriate and repeatable fits. So we've established, you know, that you have the passion and the determination to improve the lives of amputees. And with our direct socket system, we are providing a appropriate, consistent fit in a very timely manner. So what are the 3 criteria for a well-fitting socket? Well, you know, it's the stiff coupling between, you know, the skeleton and the prosthesis. We've got, you know, multiple different densities of tissue in there. We've got, we want to have no tissue damage, and we want minimal discomfort. And I always thought that was rather interesting. And I remember, you know, in private practice, I had honestly said that a really good socket is mostly comfortable most of the time. And anything that we can get beyond that is the icing on the cake. So with direct socket, we're having a more consistent way to create a socket that is as stiff as possible, with, you know, little to no tissue damage and with minimal discomfort. So how do we go about doing this? Well, we have the idea of the different tissues. So we have the bone, the soft tissue, you know, such as the adipose tissue, the connective tissues, and, you know, scar tissue. And if we think about how all these different tissue densities interact inside of a prosthetic, that is where we have to come into finding how do we design that socket so that it actually applies the appropriate pressures. This is not a new concept. We've been working on this. Sorry, there we go. Been working on this since, you know, way back. So back in 1969, our friend here, Mr. Gardner, was looking at how do we directly form a prosthetic socket right onto a limb. And in that, he was limited with the technology at the time. So he was working more along the lines of a patella tendon bearing socket with socks and actually utilizing a vacuum. So, you know, trying to take out as much void out of the socket as possible to create as intimate of a socket. So from there, we move up to, zoom in on this one here too. So moving up into more of a conventional approach. So if we think about back then, we were using patella tendon bearing, we were having more specific pressure distributions on the limb, and in this, doing a shape capture with a hands-on casting procedure. So the problems there are the repeatability, the consistency of the cast rectification. So if we look at, you know, practitioner A, B, and C, even inside of the same office, we'll have really high inconsistencies. Also, we find that with patella tendon bearing sockets, we have I want to call it a guesstimate or more of a a trial and error on how much pressure will these different tissue types take in. So with the introduction of silicone liners, we have the ability to protect the skin and suspend the prosthetic and manage tissues better. So direct socket came into play, back with the clinical considerations there with compression casting. We picked back up on that back in 1989. I show you this timetable because this isn't something new. This is something that we've worked on. But what I find most interesting is as we have made improvements to the way we provide prosthetics, back in 1995, when it was introduced, it was deemed a threat to the industry, which I find amusing that too often when we find a better way of being more consistent and providing a better service, we as a field look at it as a challenge to us rather than something that improves us, makes us better. So we have built on this, and built on this. And in 2019, we actually changed the way that we do everything. We do all of our training. And the clinical education protocols changed to consist of two-day sessions separated into session 1 and session 2 to provide more structural education, repetition, and increased adoption and success. This way, practitioners that were with more typical limbs could progress to more challenging and complicated limb shapes. It has taken over all around the world and has become more and more popular because of the opportunities that come about. So why does it work? Well, we have the concepts of, we have reliefs. Reliefs are not, voids. They are, reduced pressure. We have tissue management with our liner selection. Frankly, Össur liners, we have so many sizes and types and material types that they are nearly custom. And in that, we can provide tissue management and compression that reduces distraction and provides a better socket envelope. The FLA, or the functional liner assessment, is important because it establishes our foundation for the prosthetic. Then we have compression. And in our compression, we are utilizing, sheaths and our bladder. So our bladder and our pump actually applies the compression to the limb. And in this creates a even radial compression. And even radial compression provides us more consistency and repeatability in our socket fit. So all those different tissue types, from the bone to the connective tissues, the adipose tissue, and the muscle tissues, all compress at different rates or under different pressures. So in this, we are generating, the optimal pressures over the different tissues. We have increased, limb tissue health. We have a structural stability of the tibia and fibula, and we have reduced rotation, as well as increased stability and suspension. We have multiple different types of materials that can be used. When we order a prosthetic socket kit, whether it's transtibial or transfemoral, we can use fiberglass, we can use basalt. If you choose to use carbon, but with basalt, I don't know why I would. All of our kits are rated to 365 pounds, regardless of the material that you're using. So in that, you have different options. We have black resin, we have clearer resin that you can actually color. With a transfemoral, we have the flexible brim that is super comfortable. Is probably the biggest benefit of transfemoral is the comfort that people have along with the control. So that even radial compression provides the stability with the subischial socket and the flexible silicone brim. So in those things, as we get through this and The biggest benefit, as far as I am concerned, is the support. So once you've gotten there and you're in the process of doing these prosthetics, whether it's the central fabrication, the design studio, or the connect or direct socket, you have support. And that's one thing that I always remembered when I was in private practice, is that I always had the support of Össur, which was one of the big reasons why I joined Össur. But in that, you've always got the support. And in utilizing Orlando Central Fabrication, communication is key. So they are your technician, and you can't expect your technician to read your mind. So, go back, talk to your tech, pick up the phone. From there, this is your link to your quiz. They're also going to send out a link to you to get your CEUs. But I'd like to open this up. If we had any questions, we can do a little question and answer.
We do have a few questions here, Brant. The first one comes from Benjamin. It is, why is ConnectTF only suitable for low active users?
Benjamin, that is a great question. And honestly, I'll be very honest, I know of several K3 level amputees that choose to wear the ConnectTF just simply because of the ease and on and off and the comfort. Now, to say that it is only for low activity, no, that's not accurate. But that is the target that we are going for, namely because of the ease of don and doff, that it can be donned while seated, completely donned and set to the proper tension. So that is a good point. No, it does not have to be for just low activity, but that was our original target.
Yeah, and I think when thinking about the ConnectTF, the adjustability lends itself to that pursuit of volume stabilization, right? And which caters typically more so to lower active individuals. He does have another question here. Can this modification, oh, I'm sorry. Actually, Kirk has a question. Does ConnectTF have an L code associated with it?
So, I mean, L coding is the responsibility of the amputee. Does it have the adjustable code? No. That is not recommended.
Yeah, and I think to reiterate that is we had to take a step back and wonder, is it patient adjustable, and is that most appropriate? In development, we did a lot of user testing, and we found that especially for lower active individuals, the compliance rate of the ability to adjust their own socket may not be suitable. However, we are looking at different options for in the future, making this something that could justify that code. In regards to the Design Studio, is this software able to be utilized to download and be sent to the in-house carver so that fabrication can be made internally rather than sending to Össur's central fab?
So yes, you can download different protocols. You can download AOPs, STLs, OBJs, the different identifiers, but obviously we want you to use central fabrication. But yes, you can download the file and use it in any way you want.
If there are any more questions, please send them through the chat. We'll be happy to address them. Brant, what's your favorite way of utilizing Össur solutions here?
So so real quick, I'm a year with Össur now, and I was in private practice, and my go-to was Design Studio. I honestly can pretty much say that I didn't cast anything in the last 2 years of my clinical practice. Everything was either scanned or direct socket. And I used Össur fabrication, got very acquainted with the gentleman in the lab, and we had a really good system set up. We communicated well. And Design Studio was my go-to because of its efficiency and frankly, my repeatability. I know I beat that to death, but being in practice, you just can't hardly keep the lights on if you're not having billable events. So I got to the point where I was very efficient and didn't spend a lot of time, didn't need to spend a lot of time on non-billable follow-ups and adjustments because I had a very accurate and consistent prosthetic socket fit that kept my amputees functional and happy.
That's awesome. It does seem like there is a few issues with the QR codes. For those that are having trouble taking the quiz, we will send that to you in an email, so long as you signed up with the proper email. If not, please just send us the chat of what that email is so we can distribute it appropriately. We do have a question here. Have you ever used ConnectTF for stubbies?
I have, actually, yes. I personally have, and actually it works fantastic. Again, it's a prosthetic socket that can be fully donned while seated. So for a bilateral individual, it's almost perfect.
Excellent. Jason has a question here. Is there any additional training? Is there a program for Össur Design Studio, and what does that look like?
So we have a couple different routes to get training. First is once you get signed on, we have our initial training. So inside of Design Studio itself are training modules that are step-by-step, walk you through different simplistic processes. As you get into that and become more comfortable with it, I also do advanced training, which is more of a deep dive. It's about a 3-hour course, and it is a very deep dive into modifications both in workflows, but also using manual tools where we can learn how to do spot and global reductions, those heat and push modifications that we make, as well as merging in a brim type for a transfemoral with a scanned limb if possible. So it's a process from baby steps to full on take a scan and fully manually modify it.
Excellent. And please, if for those that are having issues with the quiz, Megan has submitted a link in the chat. Please just click on that to be sent to the appropriate page where you'll be able to fill that out. In terms of the training for Design Studio, Brant, are there any CEUs associated with that?
Yes. So the webinar is 3.25, and the in-person, I want to say, is 3.75.
And what if I have a patient in mind? Can we go through the process with a specific patient?
That is actually what I prefer to set up. If we are going to do advanced training, I actually ask you to get a couple patients, have a transfemoral and a transtabular, whatever you're wanting to learn. I want us to have an interaction. Our advanced trainings are literally not me teaching you, it's me helping you walk through the process. So actually, I make you do all the work, but you'll come out of it being very successful and knowledgeable and comfortable with Design Studio.
Is there a fee to use Össur Design Studio other than the cost of what we purchase from the central fab?
Yes, so there is a subscription, which I encourage you to talk to your Össur area manager to look at getting pricing for the Design Studio applications or OPS.
Excellent. Another question here, is Design Studio only suitable for prosthetics?
As
Yes.
I said before, yeah, it is. It's designed for prosthetics in mind, yes.
Okay. Excellent. There is a request here for the seminar to be reviewed online. We will be sending out educational assets associated with this training. And if you would like an online review of this, we do plan on creating educational assets that can be associated with this as well. So please stay tuned, and it will be followed up in an email for you. Any other questions, please hit the chat. We still have about 5 more minutes here. So Kirk has a question. In your opinion, Brant, why do you like basalt? Could you tell us some of the benefits over carbon or fiberglass?
So basalt, if you haven't used basalt, it's a little bit thicker fiber compared to carbon fiber. So a couple things that I love about it. One is it's beautiful. It makes an absolutely beautiful socket. Second thing is it's not itchy grinding on it. So as in fiberglass or carbon fiber, the itch factor is almost zero, and the edge that it creates at the proximal trim line of your socket is much nicer. It's actually got a little bit of a roundness to it, so it's got a nice smooth edge that doesn't cut into sleeves as easily or damage liners or clothing as much. And it is my personal favorite.
Great. Any other questions? We still have time here. How does the pigment work with basalt?
So
for direct socket.
Yeah, I like to. I personally like to throw a little blue into the material, and it almost gives it a little iridescent look in the sunshine. Also, red looks nice. But yeah, adding colors gives it a very. It doesn't change the color of the basalt, but in between the fibers, it gives a really unique appearance. White almost looks like snakeskin. It's really cool.
Oh yeah. How about for the Connect TF? If somebody wanted to use any liner, or is it specific to Össur liners?
So yeah, so it's specific to Össur liners in that we design that from the ground up, and I know it's kind of difficult to see in there, but it matches up with our liner profiles. And one of the things that makes a even radial compression socket, whether it be direct socket or Connect TF, one of the things that makes it work is our liners. So Össur liners are very good about reducing or eliminating distraction and tissue management. So in that, we highly recommend and say that to be successful, you have to use Össur liners with Connect TF.
Fantastic. All right.
Can I one more thing real quick, unless there's another question. The other thing with Connect TF that I didn't go in on, adjusting these sockets literally requires 2 wrenches. So I've got a 4mm and a 6mm wrench, and to adjust tension is literally just a little torque wrench. But you can actually make these adjustments on the limb with 2 wrenches. All you need.
Love that. We do have a question here regarding direct socket.
Yes.
Is it available for all suspension types?
So yeah, any of our Össur suspensions, whether it be locking or lanyard or, well, our Össur lanyard, locks, expulsion valves, Unity elevated vacuum, and our hybrid locking system. And actually, the system, so our adapter plates on these sockets here that we fabricate allow us to interchange suspension types without remaking the entire prosthetic. So if we started out with somebody in locking and wanted to transition them to a unity system, we can do that without remaking the entire socket. And the sockets are designed and fabricated for our 3mm liners. So in that we can change from a cushion liner to a locking liner, or from a locking liner to a hybrid liner, or to a seal-in liner. So we can make these changes for these amputees to suit them without remaking the entire prosthetic.
It's nice to have extra tools in the tool bag for a prosthetist. Brent, you did a great job. Thank you very much. We can conclude now. I appreciate everyone here on the call.
Thank you for your time.